Hello everyone, welcome to another interesting session of my project ideas. Today's topic is GCD of two numbers, that is greatest common divisor of two numbers. This topic sounds very familiar, right? Like we studied it when we were in school, normal maths. And some of us already know how to code it, and some of us might not know how to write a program on GCD, so don't worry. We are going to write a naive approach as well as an efficient approach to find out the GCD of the two numbers, keeping in mind the time complexity. Okay, so here we go. So just a quick sneak peek. What is GCD? Suppose a number A is 45 and a number B is 30. So the divisors or the factors of 45 are 3 and 3 cross 3 cross 5, or 3 multiplied by 3 multiplied by 5. If you prime factorize 45, it's better to say that way. So if you prime factorize 30, you get 2 into 3 into 5. So the common factors here are 3 into 5. Multiplying them, you get 15. Easy peasy. So now you know that GCD and HCF of two numbers basically is the largest number that divides both of them. A simple explanation or a definition, you can say. No brainer. Then there is a method to find out the GCD, that is a very popular method, that is called Euclidean algorithm by subtraction. This method basically relies on finding the GCD of two numbers by repeated subtraction. What is the ultimate process? What do we follow? First, initialize two numbers A and B where A will be greater than B. Then subtract the smaller number B from the larger number A. Then replace the larger number A with the result of the subtraction. Here there is a typo. Here we have multiple 3, no worries, and it's understandable, right? A. Okay. Yes. So replace the larger number A with the result of the subtraction. So when you repeatedly subtract, the result of the subtraction must be reinitialized to the variable A. Then repeat the subtraction process, carrying the same process further. Then continue until the result equals one of the numbers being subtracted. Suppose here A is equal to 48 and B is equal to 18. Subtract 18 from 48, you get 30. 30 minus 18 get 12. 18 minus 12 is 6. 12 minus 6 is 6 and 6 minus 6 is 0. So here you got 0. So before the step, you get an answer 6. So this is basically the GCD of 48 and 18. If your GCD will be greater than 1 or the result is greater than 1, then that result is GCD. If the result is 1, then you be rest assured that the two numbers that you took, they were co-prime numbers. So basically they both were prime and they had no common divisor other than 1. Okay. So here is a pseudocode for the approach that I said you, the Euclidean method. So I already explained you the Euclidean method. I will really recommend you to pause this video for a second and try to write down the pseudocode for the approach, after which we'll be moving towards the other algorithms. So I hope you got the code. If you did not, here is the answer. Have a look. It's simple. I have taken a function DEF, that is definition of the function GCD, and taken the parameters A and B. If A is double equal to B, that is if A and B are equal, I have returned A. If A is greater than B, then GCD of, so it's a recursive function, right? So GCD of A minus B and B is returned, else GCD of A and B minus is returned. This is pseudo function, the pseudocode. Okay. So in the Euclidean algorithm by subtraction, so what did we do? Our goal is to find the GCD of two numbers A and B using subtraction, and the process we already discussed before. So let's have a look at the example. Suppose A is equal to 98 and B is equal to 56. Have a look at the bullet points that have been written here. So 98 minus 56, you get 42. Now A will be replaced by 42 as we discussed in the previous slide, and B is 56 again. Then again, 56 minus 42 is 14. So A will be 42 and B will be replaced by 14. Then 42 minus 14 into 3 gets 0. So GCD is. Got it? So GCD of the two numbers. So these are the key points. Just have a look here. GCD of two numbers does not change if the smaller number is subtracted from the larger number repeatedly. Key point. And you have to continue subtracting till one of the number is 0. So the remaining non-zero number is the greatest common divisor. Got it? Next. So we learned about the pseudocode, we learned about the process, we understood the process. Now our task is to code it. So let's move to the VS Code and let's write down a code. So the code which we are going to write is going to have a time complexity of big O of max of A and B. And the space of that will be, so max of A and B is, so what number? If A is 5, B is 10, so big, it's going to be big O of 10. It's a constant, right? And auxiliary space also will be the same. So I will recommend you again to pause this video and write down the code by yourself. Then come and compare it with my code. Okay. So let's code it. Here I have already created a file in the name of GCD of 2 numbers. So let's write it. You can write in any programming language, but I prefer Python here. So I have taken a function GCD and I have taken the parameters A and B. So if A, let's put our conditions, A is double equal to 0, then I'm gonna return B. Okay, got it? So if B is double equal to 0, I'm gonna return A. Okay, done. Then if A is double equal to B, I'm gonna return A. These are the same things that we studied, we learned in the slides. So I'm just following the process. So this is the base case. So if now we are going to look at the case where A is greater. So let's see if A is greater than B. What are we gonna do? Write down in the comment box. What are we gonna do? What are we gonna return? We are gonna return GCD of which is greater. A is greater. So A minus B and B. Okay, because A is greater here. Then if I see that A is not greater than B, that means B is greater than A. So what I'm gonna return? Same thing, return GCD of A comma B minus A. Okay. So now let's put our what do you call numbers. Suppose I take a number A as 98 and number B as 56. Let's see what happens. We have to give a print statement as well, because how do we get the output otherwise? So GCD of A and B is what? It's GCD A, B. So it's clear, I guess everything is sorted. So now let's save it, run it. So it says clear the terminal first. Let's run it again. Here. So GCD of 98 and 56 is 14. This is clear to you? Now let's move to the next section. I hope you wrote the code yourself and you came and checked it. Now, so here now what we have done is the algorithm's worst case time complexity is we go of log of min of AB. So let's see how do we get the optimized time complexity here. So let's have a look at the derivation first. So the pattern is it follows a Fibonacci sequence for n steps. So the numbers will be Fibonacci n and Fibonacci n plus 1. So this is the optimized version. The worst case time complexity will be when for n steps A will be greater than or equal to Fibonacci of n and B will be greater than or equal to Fibonacci of n plus 1. Fibonacci series growth follows a ratio, the golden ratio of root 5 plus 1 by 2. These are certain facts which you do not need to know. The important thing is you should know the code part and the time complexity. So the complexity which we are gonna get here is big O of log of min of A and B. So you are going to get the minimum value. That also is inside a log function. So your time complexity is reduced drastically. Okay. So just do not have a look at the derivation. This is just for your information, like to get to know where it came from. It's not a big deal. So if you want to know, obviously you can go through it, but it's not required. So the important part is the coding section. So let's code here. So what I need to do is I need to create another file saying GCD of 2 numbers optimized.python. Okay, our file is created. Let's close this. Okay, let's write. So the function is again def, that is the normal way of writing. GCD, let's take two parameters a and b. Here we are. Then return a if b is double equal to 0. Else, what you need to return? GCD of b comma a mod b. So this is our whole concept. This is the whole gist or the whole algorithm of the program. So this function basically carries your program. After there is nothing. So a is equal to 98 and b is equal to 56. So now let's have a printing statement. F of, let's say, GCD of your a and b is GCD a comma b, and we are done. So let's have a look at the output here. So the GCD of the numbers 98 and 56 is 14, but it reduced your time complexity drastically. So I hope this whole algorithm, the GCD, was clear to you. You got to know about the naive approach as well as the efficient approach. So for more interesting project ideas, stay tuned to this channel and happy learning, guys. Thank you.